So the topic for today is equation of a straight line. So generally, we know that the general form of the equation of the straight line is y is equals to mx plus c. Here, the two things which are of great importance are, number one, it's the gradient, and number two, it's the y-intercept. So we know m is the gradient here and c is the y-intercept. So the general form of equation, so that we can get the equation in its real form, which is y equals mx plus c, is actually coming from the gradient formula, which is m equals y minus y1 divided by x minus x1. So here one thing is for notice, y and x equation should always be represented with respect to x and y. Therefore, in place of y2 and x2, I have written y and x, and this means if on a line I have the gradient and I have a point with coordinates x1 and y1, I can just very easily make the equation of the line, and we can say from here that the general form of equation is y minus y1 equals the gradient times x minus x1. So this is the general form of the equation of a straight line. So again repeating, the important thing that we should be having to get the equation of this line is the gradient, and number two, it's any point which lies on the line x1, y1. So let's do a question to get the concept more clearly. The gradient of a line is given, and this gradient is a 4 by 3, and this line passes through the point P with coordinates -6 and -1, and we are supposed to get the equation of a straight line. So to get the equation of this straight line, I will simply be substituting these values in the line equation, which is y minus y1 equals the gradient times x minus x1. So y1 is a -1, gradient is a 4 by 3, and x1 is a -6. Solving it further, it's y plus 1, which is equals to 4 by 3, and x plus 6, or I can say it's going to be 3 times y plus 1, which is equals to 4 times x plus 6, or I can say it's a 3y plus 3, which is equals to 4x plus 24. Or I can say this is 3y, which is equals to 4x plus 24 minus 3, or 3y is equals to 4x plus 21. So this is the general form of the line, which is very much accepted in the O-level or A-level examination. But if you wanted to bring it to the form y equals mx plus c, then just take the 3 on the other side so that it becomes 4 by 3x plus 21 by 3. And here we can have it in the form of y equals mx plus c, so that your m is 4 by 3 and your y-intercept becomes a 7. So both the forms are representing the straight line equation here, and both the forms are considered correct. So find the equation of the line AB with given pair of coordinates. So if I'm supposed to get the line equation with the given pair of coordinates A and B, such that A is 9 and -3 and B is -6 and -2, then to make the line equation, I know I should be having two information. Number one, it's the gradient, and number two, it can be any point which lies on the line. Any point which lies on the line, meaning I can pick any of the 2 points from A and B to get it substituted for x1 and y1. So if I take this point as A, it is going to be 9 and -3. Next thing is to find the gradient, And to get the gradient value, we know that gradient will be represented by yb minus ya divided by xb minus xa. So this can be equal to -2, -3 divided by -6 minus 9. So this gradient value is going to be -2 plus 3 divided by -15, or I can say that the gradient value here comes out to be a -1 over 15. So I have the gradient value. I know the line equation. It's y minus y1 gradient times x minus x1. Substituting y1 as -3, gradient as -1 by 15, and x minus 9. And solving it further, this is y plus 3, which is equals to -1 by 15, x, and a positive 9 by 15, which can further get simplified to 3 by 5. So I can say that this is a -1 by 15 x plus 3 by 5 minus 3, or I can say that this is a -1 by 15x minus 12 by 5. So this is going to be the line equation for the given pair of coordinates A and B in the question. And for the same equation, we could have represented it as y equals, if I take the LCM, I should have said it's minus x by 15 minus 12 into 3 divided by 5 times 3, giving me a 15 as denominator. Or I could have said it's 15y, which is equals to negative x negative 36. Or I could have said it's a 15y plus x plus 36, which is equal to 0. So this is another form of the equation 15y plus x plus 36. And so here I can see that I have represented the straight line in two formats. One is the format which is y equals mx plus c, and the other is the format which is ay plus bx plus c, which is equals to 0. So both of the formats, they are accepted as the line equations, and sometimes in the question they do ask us to represent the equation as ay plus bx plus c. So it's the last format that we are going to choose for the answer, and y equals mx plus c, that can also be the line equation. So both of them, both the formats are obviously correct for the straight line equation. Find the equation of the line through the point -1 and 3. So for the solution, let's start taking in the data. We have the point which is -1 and 3, and this is parallel. This is parallel to the line with the equation which is 2x minus 5y, which is equals to 10. So 2x minus 5y is equals to 10. The line is actually parallel to this line, and for parallel lines we know that the gradient is the same. So from the line equation that is given to us, I can say that this is 2x minus 10, which is equals to 5y. Or I can say it's a 2 by 5x minus 10 by 5, which gives me a 2. This equals to y here. So y is equals to 2 by 5x minus 2. And from here, I can say that this 2 by 5 is actually the gradient value. So the gradient that I have is a 2 by 5, and the required equation is parallel to the line. Therefore, I can say that the gradient for the required line is also going to be a 2 by 5. So for the line that we have to make, it's the point P that is given, which is -1 and 3. We have found the gradient by rearranging the line equation in the format y equals mx plus c. And we know that line equation is y minus y1 is equals to gradient times x minus x1. Substituting the values, this is y minus 3, which is equals to 2 by 5, and x minus minus 1, or we can say this is y minus 3 equals 2 by 5 and x plus 1. So this is basically the line equation that we have, but then simplifying it further, I can say it's a 5y minus 5 3 is a 15. I have taken y to the other side and multiplied y minus 3 with that 5, and then this will be equal to 2 times x plus 1. So it's 5y, which is equals to 2x plus 2 plus 15, or 5y, which is equals to 2x plus 17. So this is the required line equation passing through the point negative 1 comma 3, having the gradient m equals 2 by 5. So find the equation of the line through the point 1 comma 8. That means for the line for which we need to find the equation, we have the point which is 1 comma 8. This is one point which lies on the line which can represent x1 and y1. And also this line is perpendicular to the line with the equation 3x minus 4y 3x minus 4y plus 4 is equals to 0. So this is perpendicular, and we know for perpendicular lines there is a relationship which says that the gradients are negative inverses of each other. So rearranging this equation in the form y equals mx plus c, I can say it's 3 by 4x plus 4 by 4, which is a 1, and then this is equals to y. I've just taken 4 to the other side and simplified it so that the gradient value here is a 3 by 4. So the gradient value for the perpendicular line is a 3 by 4. Then for the required line, it has to be the negative inverse. Therefore, negative opposite, I have to have the opposite sign, and then inverse of 3 by 4 is going to be a 4 by 3. So I have the gradient of the line, which is a negative 4 by 3. So again, I have the point, which is 1 comma 8. I have the gradient of the line, which is a negative 4 by 3. I can very easily make the line equation by using the formula y minus y1 is equals to gradient times x minus x1. Substituting the values, it's y minus 8, which is equals to negative 4 by 3, and x minus 1. 3 times y minus 8 will be equal to negative 4 times x minus 1, or 3y minus 24 is equals to negative 4x and a plus 4, or I can say it's 3y plus 4x minus 24 and a minus 4, which is equals to 0. And the required line equation is 3y plus 4x minus 28, which is equals to 0 here. So this is the line equation that we can have for the line passing through the point 1 comma 8, having the gradient negative 4 by 3. So now let's do the question, which says the diagram shows triangle ABC where AB is perpendicular to BC. So whenever we come across the word perpendicular, do not forget that perpendicular has a relationship with respect to the gradient. So that means this question is hinting us to use the gradient values with respect to AB and BC. Then A is the point negative 6 comma 6 and B is the point negative 5 and 2. The gradient of AB, now if I start taking in the data, so for the data, the first thing that I know is that for this triangle, AB is perpendicular to BC. That means the gradient of AB times the gradient of BC should be equal to negative 1. A is the point which is negative 6 and 6, and B is the point which is negative 5 and 2. So from the given points A and B, I can very easily get the gradient of AB, meaning I can have the gradient of BC as well. Second thing is the gradient of AC. The other information that we have is that the gradient of AC is equal to negative 2 by 9. So find the coordinates of C. C is the common point for AC and BC. Therefore, if I can have the equation of AC and BC and I can solve them simultaneously, I can get the coordinates of C very easily. So this is the mind mapping that I can do before starting the question. So now let's start getting the information and then getting the unknown values to have the line equations for AC and AB. So I need, first let's write it down. I need the equation of AC. I need the equation of AB, equation of BC, and then I will be solving the two simultaneously to get the coordinates of C. So this is the mind mapping that we have up till now. So let's start getting the values. AB is perpendicular to BC, and as discussed earlier, gradient of AB times gradient of BC will be equal to -1. So I can get the gradient of AB by using the coordinates of A and B. So I can say that the gradient AB will be equal to 2 minus 6 divided by -5 minus -6, and this will give me a -4 divided by -5 plus 6, which is a 1. So I will be having the gradient of AB, which is a -4. So this means that if the gradient of AB is a -4, then AB and BC being perpendicular to each other, this was given in the question, AB and BC perpendicular to each other, I have the gradient of AB which is a -4. Therefore, I can say that the gradient of BC needs to be a positive 1 by 4 here. Now, to get the equation of AC and equation of BC, for AC, the question has given us the gradient, and this gradient was a -2 by 9. So equation of AC, for the equation of AC, I have the A coordinates, which are -6 and 6. The gradient value is also given. It's a -2 by 9. I know that the equation is y minus y1, which is equals to gradient times x minus x1. So substituting the values, this is y minus 6, which is equals to -2 by 9, and x minus minus 6. Or I can say it's y, which is equals to -2 by 9x, -2 into 6 divided by 9, and then I'm taking -6 from the left side to the right side, changing its sign. So solving it, I have the equation of AC, which is y is equals to -2 by 9x plus 42 by 9, or I can say that this equation is a -2x plus 42 divided by 9. I'm keeping it in the y format because I know that I have to solve the two equations simultaneously. C being the common point of AC and AB, I have to get the equation of AC, and then I need to have the equation of BC as well. So for the equation of BC, I got the gradient value, and this gradient value was a 1 by 4. I do have the point B. This was given in the question, and the point B given is a -5 by 2. Again, substituting in the line equation, y minus y1 is equals to the gradient of BC times x minus x1. I can say it's a y minus 2, which is equals to 1 by 4, and x minus minus 5. Solving it, I am going to get 1 by 4x, positive 5 by 4, and a plus 2. Or I can say it's y equals 1 by 4x plus 13 divided by 4. So y then will be equal to x plus 13 divided by 4. So I have the two equations. I can solve the two simultaneously, as again repeating C is the common point for AC and BC. I can solve the two equations for AC and BC simultaneously to get the coordinates of C. So I have the two y equations. Equating them, I can say it's negative 2x plus 42 divided by 9, which should be equal to x plus 13 divided by 4. So it's 4 times negative 2x plus 42, which will be equal to 9 times x plus 13. Negative 8x plus 168 will be equal to 9x plus 117, or I can say it's going to be negative 8x negative 9x, which is 117 minus 168, or negative 17x will be equal to negative 51. The negative gets cancelled, and x value here is going to be 51 divided by 17, and I can say that this x value comes out to be a 3. To get the y value, I can substitute this x in any of the two y equations that we have. Let's say I substitute this in y equals x plus 13, y equals x plus 13 divided by 4. So I can say it's y is equals to 3 plus 13 divided by 4, and it's a 16 by 4. Therefore, y is equals to a 4. So this gives me the coordinates of C, which are 3, 4 here. So this is how we get to solve the line equations, and over here we have seen that we can apply the parallel lines concept, the perpendicular line concept to the line equation for y minus y1 equals gradient times x minus x1.